Hello. Today we're gonna start with exponential rules or exponent rules. So just to review, if we have a positive integer exponent, whoops, that means we repeat the base number. So this is called the base, and this is the exponent. And a to the n means we multiply a n times, right? So a total of n times. So for example, if we had 2 to the third power, that means I multiply 2 by itself 3 times. Okay, so that's the definition of exponents. And from there, we have multiple properties that come up. So, properties. The first one, if we have the same base, so for instance, if we have 2 to the third times 2 squared, then what that means is we have 3 2's for the first one, and for the second one I have 2 multiples of 2. So in total I have 5 copies, right? So whenever you have the same base and a different exponent, instead of working it out like this, we can take a shortcut because we just add up the exponents. So up here is the reason why, and this is the property that we can use from this point onward. And another one is, let's do something small. So 2 to the third to the second power. So if we have power of powers, then by definition, this is 2 to the third times 2 to the third. But if we expand that out and collect all the terms, we get 2 to the sixth. So if we have a to the n to the m, we can just multiply the exponents. And this is a review from 103. So if you're having issues, please, I'm coming back on Wednesday, so I'll be in class on Thursday. So stick around after class and we can go over some of these in more detail. The next property is when we have different bases but the same exponent. So say we have a to the n and b to the n. If they have the same exponents, then we can collect the bases and put it to that same exponent. So let's say we have 2 to the third and 3 to the third. This, we can write it as 2 times 3 to the third power, right? Because 2 times 3 to the third power means 2 times 3 times 2 times 3 times 2 times 3. And since multiplication is commutative and associative, we could collect all the 2's, 1, 2, 3, so we get 2 to the third power, and then we get 3 to the third power because there's 3 of 3's. So that's the rule for when we have different bases but the same exponent. Then we can multiply the bases together and the exponent stays as a quantity power. And the last one that we have is when we have division. So if we have the same base and we're dividing, let's look at it through an example. So say we have a to the fifth over a to the third. That means I have 5 copies of a's up top, 3, 4, 5, and then I have 3 copies of a on the bottom. But whenever you have the same number, top and bottom, so a divided by a is just 1, so we can cancel out 3 copies, and we're left with 2 copies on top. Right, so what we're actually doing is we're subtracting the exponents, and that's the result of this division.